أعوذ بالله من الsyaitan rajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi semua. Jadi kita bersiaran kali ini untuk menyambung kembali kuliah kita iaitu berkaitan dengan fluid static buoyancy. Okey, ini adalah sambungan daripada chapter 2. Kita lihat dia punya pecahan dia. So, introductions, buoyancy could be described as the floating ability of an object or a tendency for an immersed object to float or to be lifted up in the fluid. Any objects, when immersed or placed in the fluid, will experience a buoyant force. Buoyant force is the net upward vertical force caused by fluid pressure difference between below body surface pressure and upper body surface pressure. Because the pressure on the bottom of the object surface is greater than one on the top surface, it results in upward force that tends to lift the object upwards, enable the object to float or at least seems lighter. So in this chapter, we have to understand about the Archimedes principle. What is the Archimedes principle? Archimedes' principle is notice that object seems lighter when they were placed in water. This is because the water exert an upwards force upon the object. The formula is about the buoyant force given by Fb is equal F bottom minus F top or F2 minus F1. So F is equal to rho gh. So we have to rho g. So A times X is equal to V. So rho GV. Therefore, the buoyant force has a magnitude equal to the weight of fluid displaced by the body and is directed vertically upward through the centroid of the displaced volume. So the result is commonly referred as to Archimedes principle. Okay. The buoyant force is depend on fluid density and displaced volumes of submerged body. This force can be assumed to act at a single point on the body, which is known as the center of buoyancy of the body. And this center of buoyancy of the body is the same as the center of gravity of the part of the body which immersed inside the water. So please look at these different types of density. Number one is the velocity buoyancy, when an object has a tendency to float, means that body weight W less than buoyancy force Fb. Number two is a category of buoyancy is negative, when object has a tendency to sink, but body weight W is more than buoyancy force Fb. And lastly is the neutral buoyancy, when an object is in a condition of balance, neither rising nor sinking, but remaining suspended at a particular depth. Body weight W is equal to buoyancy force. So buoyancy is the different object show different floating tendencies. The submarine is designed to be able to adjust its ballast to hover at any depth, dive deeper or rise onto the surface and float. The Buoyancy life jacket, boat and ship are obviously designed to be float. The ship, for example, a tow is made out of several thousand tons of steel or iron. When it's shaped in such a way that after some amount of immersion in water, it displaces the volume of water sufficient of counter its weight. Hence the reason for flotation. As the ship is loaded, it sinks deeper, displacing more water, and so the magnitude of the buoyant force continuously match the weights of the ship and its cargo. Why boat float while elephant sinks? So we have to discuss it from your group. Why whale float is in the seawater but could not float in the air? And lastly, how could ship weighing thousands of tons floats on water while a small coin sinks right to the bottom? So this is a rule of thumbs. Okay, the object with a greater volume have greater buoyancy. For example, like the steel ship, which are built with a hollow shape, will float on the seawater, while the steel block with the same masses will sink right to the bottom. And secondly, the object or substance which is less than the fluid will allow afloat. For example, like wood block afloat on the water while oil will lay on the water surface. And lastly, any change in the floating level, for example, like fresh water is less than the salt water, so a ship floats lower in fresh water than it does in salt water. Warm water is less than cool water, so a ship floats lower in the water if the water temperature rises. So this is a procedure how to solve the buoyancy problem. So determine the object, firstly determine the object of the problem situation. Are you going to find a force or a weight or a volume or specific volume, a specific weight? Number two is draw a free body diagram for the object in the fluid. Show all the force that acts on the free body in the vertically direction, including the weight of the body and the buoyancy force and all the external force. If the direction of some force is unknown, so assume that most probably direction and show it on the free body diagram. And thirdly is write the equation of the static equilibrium in the vertical direction. Summation of FB is equal to 0, assuming that the positive direction to be upwards. Okay, this for this procedure is solve for the desired force, weight, volume, and specific weight, remembering the following concept. Number one is the buoyant force is calculated from FB is equal to gamma fluids times the density submerged is equal to rho fluid times G times rho submerged. The weight of the solid object is the product of its total volume and its specific weight. Means that W is equal to gamma rho. An object which average specific weight less than that of the fluid, it will tends to float because W is less than FB, which is object submerged. Number four is an object with a very specific weight greater than that of the fluid will tend to sink because W is more than FB with the object submerged. And lastly, neutral buoyancy occurs when the body stays in the given position wherever they submerge in the fluid. An object whose average specific weight is equal to that of the fluid is naturally buoyant. So these are some of the example calculation. You have to understand about the rectangle pattern with the 6 meter wide and 12 meter depth in the fresh water. How to determine the weight of the pattern, the buoyancy depth in the is float in the seawater, and lastly the weight that can be borne of the maximum buoyancy depth in the 2 meter. So this is a calculation how to determine the weight of the ponton, and the weight of ponton is equal to FB, and then the how to determine the FB. So write the equation there, so you have the answer. So this is an example of the question, and try to solve it by your group. Okay, this is the answer of this example of 3.3. Okay, and then the example 3.2. Okay, the 3.2, you have to try to understand and try to do it with your group. And then this is a sample of the content they use in the environmental or in the real situation. Number one and number two is about the conventional fixed platform. Number three is a compliant tower. Number five is the vertical more tension length and mini tension length platform. Number six is a par. Number seven, eight is semi-submerged submersible. Number nine is the floating production storage and offloading facilities. And lastly is the number 10, the subsea completion and tie back to the host facility. So that's all. This is a sample of the content uh, which is running right now, especially in the Sabah Ship Petroleum, the deep water engineering, and then this is also about the content. Sorry, about the buoyancy concept of the situation. Okay, that's all for now. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, Assalamualaikum. Kehadiran tadi boleh rekodkan di sini untuk pemerhatian semua. Jadi saya harap semua dapat ambil perhatian untuk kehadiran rekod di sini.